Assalamualaikum and hi everyone. Today we will discuss about 1.1 Coulomb's law. Example 1. How to sketch the electrostatic force on a charge. You highlight here acting on a charge. You have a 2-point charge with the same sign separated with R, and then how to draw electrostatic force acting on both charge. The force acting on Q1 due to Q2 repulsive force. The direction is to the left. And then you write down the rotation state is F12. What happened to the force acting on Q2 due to Q1? The direction of F21 to the right. Because this one is a repulsive force. It have a same sign. The notation state you can write down as a F21. The magnitude of F12 equal to the magnitude of F21 but opposite direction. Next, second example. How to sketch the electrostatic force acting on Q2 only. Now you have a 2 charge which is a opposite sign. Q2 is positive. Q1 is positive, Q2 is negative, are separated apart with R. Now you must draw the force acting on 2 only to the left because the charge has a opposite sign. The force is called as a attractive force. And then the notation state you can state right F21. Now we proceed about example 3, calculation for electrostatic force. The question, 3-point charge are firmly held on a straight line of 4 cm in length as shown in a figure below, where Q1 equal to positive 10 microcoulomb and then your Q2 equal to positive 5 microcoulomb. Q3 equal to negative 8 microcoulomb. You need to calculate the resultant of electric force acting on Q2 only. Please remember the electrostatic force is a vector quantity and then it have a magnitude and direction. When you adding the electrostatic force, you need to consider the direction of all forces using the vector component. How to solve the problem? Step 1. Draw the electric force vector diagram acting on Q2 only. The force acting on Q2 due to Q1 is a repulsive force because Q1 and Q2 have the same sign. Therefore, the direction of F21 is to the right, while the force acting on Q2 due to Q3 is attractive because Q2 and Q3 have the opposite sign. Therefore, the direction of F21 is also to the right. Next step. Step 2. By using the Coulomb's law equation, find the magnitude of each of the electric force. The magnitude for F21 equal to KQ2 Q1 divided by R squared. Substitute the value. 9 times 10 to the power 9 multiplied by 5 times 10 to the power negative 6 multiplied by 10 times 10 to the power negative 6, you divide by value for R 0.02 squared equal to 1125 Newton. This one is to the right. And then calculate F23 equal to KQ2 divided by R squared. Value for K 9 times 10 to the power 9. Value for Q2 5 times 10 to the power negative 6, and then Q3 8 times 10 to the power negative 6. You divide by R 0.02 squared. You get 900 Newton to the right. Please remember when you solve the problem, no need to substitute the negative sign for a negative charge. Step 3. Electric force acts as a vector, so you need to consider the direction. Therefore, the resultant electric force acting on a Q2 is F net equal to F21 plus F23 equal to positive 1125 to the right plus positive 900. Positive here represent direction of the F23 to the right. So F net can be equal to 2025 Newton to the right.